In this module, we shall learn the properties of a parabola. A parabola is a locus of all points in a plane which are equidistant from a fixed point and a fixed line. The fixed point is called the focus and is denoted by F. The fixed line is called the directrix and is denoted by D. The axis of a parabola is the line passing through the focus and perpendicular to the directrix. The point of intersection of the parabola and the axis is called the vertex. Consider a parabola with its vertex at origin and the axis of symmetry along the x-axis. The standard equation of this parabola is y square equal to 4ax. Consider a point P on the parabola. By definition, distance PF should be equal to PK. The ratio of PF to PK is called eccentricity and is denoted by E. As PF is equal to PK, the eccentricity of the parabola is equal to 1. Now, let us see the graphical representation of the parabola represented by y square equal to 4ax. To trace a parabola, we need to know 3 parameters. Click each tab to learn more. At a point where x-axis intersects the parabola, y equals 0. Substituting this in the standard equation of a parabola, we get x equal to 0. So, x-axis intersects the parabola at the origin. Similarly, at the point where y-axis intersects the parabola, x equals 0. Substituting this in the standard equation of a parabola, we get y equal to 0. So, y-axis intersects the parabola at the origin. For the parabola y square equal to 4ax, y is equal to plus or minus square root of 4ax. This means, for each positive value of x, there are 2 equal and opposite values of y. So, the parabola is symmetric about x-axis. For the parabola y square equal to 4ax, y is equal to plus or minus square root of 4ax. So, as x increases, the positive values taken by y increase, whereas the negative values taken by y decrease. Hence, the parabola extends to infinity on the right side of y-axis. Also, y is real if and only if x is non-negative. So, the parabola lies wholly to the right side of y-axis. Now, let us apply these parameters and trace the parabola y square equal to 4ax. As per the first parameter, the parabola y square equal to 4ax passes through the origin. We can see that there are infinite parabolas satisfying this condition. Now we apply the second parameter. For the parabola y square equal to 4ax, the axis of symmetry is x-axis. Of all the orientations shown, only 2 satisfy this condition. As per the third parameter, the parabola extends to infinity on the right side of y-axis. We can see that there is only one such orientation of parabola. We can trace multiple parabolas with this orientation depending on the value of a. The focal distance is the distance of a point on the parabola from the focus of the parabola. Consider a point P, x1, y1, on the parabola y square equal to 4ax. The coordinates of the focus F are a, 0, and the equation of the directrix is x plus a equal to 0. By the definition of a parabola, PF is equal to PK. The perpendicular distance PK can be expressed as shown. On simplification, we get PK as the modulus of x1 plus a, which is the focal distance of point P. Next, let us see the method to calculate the length of the latus rectum. The latus rectum is the line parallel to the directrix which passes through the focus of the parabola. Let LFL' be the latus rectum of the parabola y square equal to 4ax. By symmetry of the parabola, LF is equal to L'(f). Let's say it is equal to k. So, the coordinates of L are a, k. Since L lies on the parabola, it satisfies the equation of the parabola. Therefore, k square is equal to 4a square. So, k is equal to plus or minus 2a. As L lies in the first quadrant, k should take a positive value. Therefore, k is equal to 2a. So, the length of latus rectum LFL' is equal to 4a. Now, let us see what we have learnt in this module. We have seen that the eccentricity of the parabola is 1. We have also derived the formulae for the focal distance and latus rectum of the parabola.